So we're on to lesson 2 here. So this is lesson 3.2. So we are now we're still looking at surface area, right? We're looking at the coverage of these shapes, but now we're looking at more complex shapes. It's not just squares and triangles now. Now what we're looking at is pyramids, cylinders, spheres or balls, and cones. And the first one we're really going to talk about here is going to be the cylinder. Now, so this cylinder here, I'm just going to zoom in. It has a couple different terminologies. First off, this is that neck of a cylinder. A cylinder itself is not that complex. It is literally a rectangle. It is literally just a rectangle that has been rolled up with two circles on each end. When you think of cylinder, you think of rectangle facing circle. That's what it is. Now, there's two things here. We do have the radius here. So we do have this radius of this circle, right? That's, if you're looking here, there's that little dot in the middle. The radius is just the length from the middle of your circle to an edge. But we also have this new thing here, circumference, which we call a C. So circumference is the whole thing. So it's the whole thing. So if I give you a circumference, let's say the circumference is 10, you know that the radius has to be half of that. The radius would have to be 5, for an example there. The circumference is always double the radius because it's just two radiuses put together. So we have a cylinder. So to find the surface area of this stuff, all we do is we find the surface area of these two circles, and then we find the area of this rectangle, and then we just add them up. That's what we do for cylinders. Now, this little big space is not supposed to be here. That's because I moved this picture down. So a pyramid, we know what a pyramid looks like. A pyramid's just an object with a triangle sides and a square base, typically. We'll look at that a little bit later. We are going to be seeing stuff that we've seen before. We are going to be seeing Pythagoras, for example. That is going to be there. Sometimes you're going to have to use that to find something, to find the actual area. So just know that this is something that we will be dealing with still. We have a cone, which is basically, it's a pyramid, but it has a circular base. This is the formula for that right here. I know it's very small on your screen, but make sure you put a box or something around it. But the area is equal to pi times r, which is this radius here, times the slant, the s. So in this case, this is the one time where, we see this, we're always like true height, true height. This is the one time you don't do that. We don't care about the true height for the cone. So it's the pi times the radius times the slant. And then we have a sphere. A sphere is just this formula here. It's 4 times pi times the radius squared. So there's only actually 2 new formulas because pyramids and cylinders are just the basic shapes we already know. It's rectangles, triangles, and circles. We just have to, do a little bit of problem solving with it. Whereas these two, the cone and the sphere, are literally just, it's a brand new formula. So pyramids and cylinders will not have their own formula. So let's start with a little bit of an example here. Oops. Where's my... Here we go. So again, this is something we should be able to kind of do. But we don't have a formula for this. This is kind of a weird oval, not quite. So how could I probably find something like this? How could I find the answer for the surface area of this thing? So length times width works for rectangles, but I don't have a rectangle. So what I want to actually do is I want to break this up into basic shapes. If I do this, all of a sudden now, what 2 shapes do I have? I have a circle and a rectangle, absolutely. I have 2 half of the circles, which is just going to be 1 full circle. Yeah. So this one's not too different than what we're used to, actually. So I always recommend Whenever we're dealing with these complex problems in this unit, do yourself a favor. Make yourself an equation. In this case, how do I find the total surface area of this thing? It's the rectangle plus the two half circles, right? That's what I mean. When I make an equation, it's like, just state, how would you find it? Oh, I'd find it by adding these 5 sides up. So that's our equation, literally rectangle plus circle. So let's do my rectangle. What's my formula for a rectangle again? A equals length, oops. Length times width. What's my length? 112.6 centimeters times my width, which is 58.4 centimeters. Right, again, the math itself is not hard. So you just go to your calculator, you put in 112.6 times 58.4, and you should get 6,575.84 centimeters squared. Make that a little bit bigger. Right, that's an important number, so I'm just going to underline it. So I've done the rectangle part. Now all I need to do is I just need to do the circle part. So first off, I technically only have 2 half circles, right? The reason I'm doing a full circle is just because I'm combining that. My question for you though is, what if I only had a half circle? How could I figure out that answer then? Like, let's imagine this part here just didn't exist. And I'm only left with
what is the just divided by half?
Yeah, I'd still do the same formula, just divide it by half at the end, right? If I only have a half of a circle, well, I'd just figure out the formula of a circle and divide it by a half. In this case, though, I have a full circle because I combine both these two sides. So what's my formula for a full circle? Yeah, A equals pi, which I'll write there in a second, and then R and then squared. So pi R squared. Now, here's the tricky part, though. What is R? The radius. But it doesn't show me what the radius is here, right? The radius is supposed to be from the center of a circle all the way to the edge, but it doesn't tell me that. So I have to use what's in this picture as a clue to get that information. How can I figure out what the radius is here? So I have to use the 2 numbers I'm given. Well, so those are the 2 numbers I am given. But so with the circle here, let's imagine this thing here, like this part in the middle doesn't really exist much. So you're thinking this 58.4? So this thing here, so 58.4, that's the length of this whole thing, right? The radius is the length of half of that. So can't I just take half of this 58.4? Yeah, so I'm just going to really quickly write that. My radius here, I know it's going to be this 58.4 divided in half. What I technically have, this 58.4, that's that circumference thing we talked about at the start, right? Technically, that's that circumference. It's the full length of a circle. So all I need to do is just cut that in half, divide it by 2. And all of a sudden, my radius should be 27. Sounds right, 0.2. No, 29.2, 29.2. So my radius is 29.2. So then all I have to do is take that information and just plug that into my little formula for the circle thing. Because I know my circle formula is it's a equals pi times radius squared. So I'm just going to put my radius, which is 29.2, and I'm going to square it. Again, look at where I'm putting this little squared part here. It's before the centimeters. I don't have an area yet. I just have a measurement that I'm squaring. So then all I got to do is just put that in my calculator, right? So your pi button, if you remember, is like kind of near your top right here. It's this little thing here below your right arrow. So it's just pi. Now you can write it in exactly as you see it, 29.2 squared. Oops. You can write it in exactly as you see it. You could put a times in here if you want, because that's technically what's happening. Either works fine. So pi, I'm just going to say 20 times 29.2 squared. And if you do that, we turn that into a decimal. All of a sudden, I have a figure 2,678, and I'll just round that. So that's equal to 2,678.65 centimeters, and that'll be squared. So the hard part with this question is just realizing that, how do I find that radius? That's the trick part of this question. And now the last thing all I have to do is, well, if I go back to my original equation, I have the square, I have the rectangle, I have the circle. All I now need to do is add these two numbers up. So if I add these two numbers up, I'm going to get 9,254.49 centimeters squared. It's my final answer. I'm going to give it a big old circle. Again, the hardest math we're doing is just plugging stuff into calculators here, but it's really thinking about the question. That's the hard part with this. So by going down to my next question here, I can see now what I'm doing is I'm finding the surface area of a cylinder, and that has a radius of 70 millimeters and a height of 300 millimeters. You notice that I'm underlining stuff. Maybe I'll highlight stuff. It's a good idea to do that. The big thing that's going to throw you off is you're going to get this wrong at some point. It might tell you, hey, the circumference is 90 instead. We care about the radius for our formulas, not the circumference. So make sure you're really paying attention to that. That will be the curveball you're going to get. There will be a trick question at some point that is going to have that. So you have to make sure it's careful. No, is it the radius or is it the circumference? So the first thing I like doing is I like drawing a nice little diagram here. So I'm just going to draw myself a cylinder. So how you do that basically is you do some weird like little circle. It's almost like an oval. And then you just connect it. You just draw some lines down, draw a nice flat base. Boom, you have a cylinder. And so let's finish filling this in. So in my cylinder, it tells me that it has a radius of 90 millimeters. So I'm going to write that in. So radius of 90 millimeters, and it has a height of 300 millimeters. They are in the same units, so I'm good that way. They're both in millimeters. And now I have everything I need. So if I want to find the surface area of a cylinder, do you remember how do I do that? That's to find the surface area of a circle. So to find this surface area of this cylinder, what I need to do is I'm going to find the area of the two circles and the area of the rectangle, right? If we think about our net here, that's all a cylinder is two circles and a rectangle that's kind of folded up. So just like always, I'm always going to put myself a nice little equation. I know it seems tedious, but I promise you it's going to be helpful. So my equation here, how do I find the surface area of a cylinder? It is literally circle plus rectangle. I know it seems tedious, but this will come in handy for you. So let's start with my circles. Because that's just the first thing I see there. So the circles, formula for that one was? What's my formula for a circle? Yeah, pi times r squared. So pi r squared. Is that big enough? So I already have my radius because it tells me up top that I know what the radius is. So what number am I substituted in for r?
90.
Just 90, right? Tells me the radius is 90, so I'm just going to put in 90 there. So it's 90 squared. Oops. It's 90 squared centimeters. It's not 90 centimeters squared, it's 90 squared centimeters because we're squaring that number. It would be millimeters. Thank you. So then all I have to do is just punch that in my calculator. So it'd be pi times 90 squared. 25,446.9 millimeters squared. Yeah, so I'm done my circles. So check, I'm done with that. That's an important number. I'm going to underline it, or you could box it. So the only thing I have left to do now is I just have to find the area of my rectangle. But what do I, so what's my, yeah, rectangle. A equals length times width. Now, this is where it gets kind of weird. If we really think about, that cylinder here, remember, so that part there is it's the rectangle. It's this part that I unrolled. I unrolled my cylinder into a rectangle. The only two measurements I have first off is the height of 300. Do I have the length of this?
Yes. Well, no, I guess.
I don't. I actually don't. So I have the height of this rectangle, but I do not have the full length of it. All I have is the radius of one of those circles. The full length of this, again, if you're really thinking about it, if I pull this up, the full length of this is not this radius. It is the whole thing. It is the rim of this. Like unfold it. If you've ever taken a can, you chop the top up and you've unfolded it. I don't know why you don't do that. If you've ever done that, the radius there doesn't work. You need the actual full length of this. So this thing here is something we have to find. That's a good guess. The 180 is still the diameter though. So it's a good guess. So the diameter itself won't work. So now we're introducing you a new thing. So what we need is we need to find, it's called the circumference. So you're going to actually write a definition here, by the way. So what we need to find is we need, oh, not that. We need to find the circumference. And I'm actually going to label this blue. And I'm going to mark that blue. So the circumference is this thing I'm drawing in blue up here. Actually, no, I'm going to erase that underline for now. So the circumference is the length of the edge of a circle. And our formula for it, it's going to be 2. So it's C, we say C, circumference is equal to 2. Ooh, make this smaller. It's 2, it's pi times radius, 2 pi r. So I'm going to recommend you guys box this whole thing, draw a big star beside it. So again, this circumference is this blue thing I've marked. It's that blue circle up top I've marked. It's the length of the whole edge of that circle. And so in this specific case, in this question, well, the circumference here is going to be 2 times pi times the radius, which is 90 millimeters. So then all I got to do is just plug that in my calculator, 2 times pi times 90. And I should get 565.49 millimeters. But I made a mistake. Can anyone catch what mistake I made there?
Should the 90 be?
The 90 itself shouldn't be squared because there's only one radius. The issue here is I squared this part down here. I'm not timesing a millimeter by a millimeter. So I'm only measuring a length. Remember, when this is squared like this, I'm measuring an area. When it's not squared, I'm measuring a distance. I'm measuring the distance that the edge of the circle is. I'm not measuring the area of the circle. Okay, so I found my circumference, which means in my rectangle, I now have the height of the length of 300, but I now also have that width, that circumference. So now I can go back to my rectangle and I can put that information in. So what two numbers am I going to multiply?
300
So 300, that's my length.
times 565.
That's 565.49 millimeters. Let me do this. Here we go. Perfect. And then all I gotta do is just times those two numbers together. I'm gonna get 220,540.8 millimeters squared. And I'm gonna underline that. That's an important number. So I now have my three ingredients to figure out what it's actually asking me. I want to find the total surface area of the cylinder. Well, the total surface area, as we did at the very, very top, circle plus rectangle. So the surface area of the cylinder is just going to be circle plus rectangle. Well, what's the area of my circle? 25,406.9 squared. Plus another circle. Plus the rectangle. So if I add all that up, it's going to be equal to, oh, sorry, this is the wrong number I've given you. Sorry, my rectangle number was wrong, guys. I apologize. My rectangle number was wrong. It's 169,647. I made a mistake there. So instead of 220,000, the rectangle is supposed to be 169,647. That's my apologies. I'll give you a second to adjust that. You might have to scratch something out. Where I got that 220,000 was, that's the total thing of the cylinder. Which is my final answer, so I'm going to give it a circle. So I'll give you a second to get caught up. Again, none of the math itself is hard. You're taking a formula, you're plugging the numbers in, and you're timesing it. The hard part, of course, is always going to be organizing it and knowing what do I do next. So it's always thinking about how do I solve this problem? Okay, so that's our cylinder. Now, the next one we see here is we have a square-based pyramid. The square, in this case, it means the bottom of it. It's a square-based pyramid. It means it's the bottom of it. And then each side of a pyramid has what type of shape? Triangles, yeah. If we think about pyramids, and if you look at a pyramid here, all a pyramid is its triangle sides. There's 4 of them, and it's going to be a square base. If I go to the net of it, oh, that's way too big. This is the net of a pyramid, right? It's a square and 4 triangles. Now, all of these triangles are going to be identical as well. So I don't need to individually calculate, okay, the north triangle, the east triangle, the south triangle, the west triangle. You find one, you know all 4 of them. So this is what our pyramid is. It's just a square and 4 triangles. So if I want to find the surface area of this, that's what's going to be my little equation. It's literally going to be 4 triangles plus 1 square. Oh, you know what? I need that. Okay. So this is my equation, right? So not too difficult. Now, remember, what's my formula to find? Let's do the triangle. What's my formula to find a triangle? Yeah, it's half times base and height. So that was what we had learned. Ooh, not that. So all I'm going to do is I'm just going to take my numbers and I'm going to plug them in. So a half times the base. Now, what's the base of this triangle? Yeah, it would be 24 meters. So, I want to erase this actually. So I'm just waiting for everyone to get caught up. So I'm just going to scroll up a second. So to the first unit. So when we're looking at a triangle, we are looking at the true height of a triangle. Now remember, this is a 3D object. So if we're looking at what our question is down here, what page was that one? Here. I have this line right here. This is what I know. Oh. So all I have right now in my equation is I just have the base of the pyramid, and I have the line that's kind of following up it. But that's not the height, right? That's the slant of it. What I need here is the actual true height of this. Like from the tip of this all the way straight down into the base of this triangle. I need the true height. Remember, heights is the thing that goes straight up. This is not going straight up because it's following up that little slant. So what I actually need here, if you look really closely, there's this line here. This is a right angled triangle. I need this line here. Just gotta erase that. Now, we haven't learned how to do that yet, so I'm just going to give that to you. Eventually, though, we're going to have to know that. This is just another offshoot of Pythagoras. It's a little bit more advanced. It's, oh, I have two sides trying to find another side. So I'm just going to tell you what that is. It was, it's the square root of 112. Um, well, if you punch that in your calculator, it still means something. I'm just giving that to you to be more exact instead of giving you all of this. We will eventually learn like how we got that number, but today's we care more about the surface area stuff. We will learn that Pythagoras stuff later because we already have the hypotenuse of that little triangle in there. We've only really learned how to find the hypotenuse so far. Now we're using the hypotenuse to find another side. So I'm just going to tell you what it is. It's root 112 meters. I know there's a square root there. It's like, what the heck is that? That's still a number. If you punch that in your calculator, you do get a number. So now I have my true height, which is just 112 meters square rooted. So cool. Now all I have to do is I just have to punch that in my calculator, right? So I take a half. Remember, don't just press, oops, backspace. Don't just press like, okay, I have a half and press times and like put all your other stuff on here. You have to use your little arrow key to move that over, right? So it's a half times 24 times the square root of 112. Don't do 112 square roots. That won't work. It has to be the square root first. And if I do that, I should get 126.996. I'm just going to go to 127. Like, that's so close. We're just going to go to 127. Keep it a nice, easy number. 127 squared meters. That's the length of a triangle, of which I have 4 of them. But I've done it. I know what a triangle is. Check. All right. So I've done the triangle. Now I just need the square. Square is pretty easy, right? That's just length times width. What's my length of this? 24. It's square, right? 24 meters times 24 meters. You punch that in your calculator, you should get, what will you get? 576 meters squared. So I underline, that's important. Okay. I have all my ingredients to solve the question, right? It's 4 triangles and a square. So I'm just going to write that. The surface area of the pyramid is equal to 4 triangles plus 1 square. You can skip that step if you want. Honestly, like you're just restating what you have up above. So it's just going to be 4 times, what's the length of one of these triangles? It's 127. So 127 meters squared. You could also just do 127 plus 127 plus 127 plus 127. You're going to get the same answer. It's the same thing. And my square was 576 square meters. You said 1,084? That's going to be equal to 1,084 meters squared, which is my final answer. So I'm going to give that a little bit of a circle here. So any question dealing with pyramids right now, guys, I will give you this little height here. We do not need to know how to find that right now. We will get to that later. That's not something we need to know right now. So I'm just going to give you the heights. Everyone have that in?
So what if that's 81?
That's exactly what it's for. Well, kind of like technically what you're doing here. So your formula to find so we have two sides trying to find a third. So it's always a squared plus b squared equals c squared, right? Only in this case, we have our c. We know what the hypotenuse of this triangle is.
Oh.
So it's 16 is equal to, we also, this is 12. Like this length of this here is 12, right? Because it's half of this. So it's literally going to be, so it's going to end up, if you use like algebra, it's an algebra question, which is why we're leaving it alone for now. But it's 16 squared minus 12 squared is a squared. So you square those up, you get 112 equals a squared, and then that's where we get that square root from.
Oh, okay.
Yeah. But so far we've only learned how to do the hypotenuse, which is why I'm just like, nope. Yeah, we'll come to that later. Okay. So this one, like I said, the math itself is not that difficult. It's just we really have to think the problem through. So now this next question here is, I have a cone that has a radius of 12 feet. Again, look at it, what that is. Is that the radius or the diameter? What's it telling you? Is it's a radius or diameter? Has a radius of 12 feet and a slant height of 15 feet. So as always, what I really recommend doing is just draw yourself a nice little picture. I'm going to do that same weird circle. I'm going to draw the cone. And I'm going to fill in the stuff it's told me. Right, so my slant height, it tells me, was 15 feet. The radius, it told me, was 12 feet. I don't know what the height of it is. I know what the slant is. I don't know what the height of it is. Now, in this case here, does a cone have a formula? Yeah, pi RS. So my surface area of my cone is equal to pi times r. You don't need to put these times in either. Times s. No, I'm going to keep it all lowercase. S is slant. Yes, yes. So where this question is going to try and trick you is it's going to give you three numbers here, and you're going to be like, crap, which one's the S? Which one's the S? Which one's the S? The S is the slant. So this one's actually probably the easiest of all of these, just because there's no trick here other than the fact that it's trying to trick you into figuring out what that true height is. We don't need the true height. This is the one exception, the only exception where we do not need the true height of something. I can use that slant here. So it's literally just going to be pi times my radius, which is 12 feet, times my slant, which is 15 feet. There's no fancy tricks here. It's, oh, it's a cone. Here's the formula. Here's the radius and slant. Punch in our calculator. So if we put that in our calculator, pi times 12 times 15, we should get 565.49 feet squared. And that's it. Okay. So like I said, that's a cone. They're not hard. Formula, plug it in, boom. We're doing another cone. What is different though? What is different between these two cones?
Doesn't have a radius.
I don't have the radius now. Instead, I have this. How can I use this to find that radius?
Divide that by 2.
Just cut it in half. This is the diameter. That's like the whole thing. I want to find the radius, so chop it in half. That's trick number one. This is two tricks. That's trick number one. Okay, I want to figure out what that second trick that's happening in this question. I know my formula. It's pi times radius. And now I can figure out my radius and my slant.
No, there's no slants.
There's no slant. This is the one where I have true height, and this is going to be really common. People are going to be like, "Oh yeah, radius and I times by this." No, your times. This is the one thing you don't times it by this true height. So I need to use this information that I have on screen here to figure out the length of this slant. But what do we see right there?
Triangle.
See a triangle. I see that I have two sides of a triangle. And I have a third side. Oh crap, that's something we learned all the way back in unit 1. So instantly what I can see here is I can see that, oh, two sides. I need to find a third side, Pythagoras. So first off, what I'm going to do is I'm just going to go through that radius thing here. So this is the 9.6 is the diameter. Which means if I divide that in 2, 9.6 divided by 2 is going to be 4.8. Is going to be the radius. I'm just really quickly putting that in there. So now I know what the radius is. All I did was chop that 9.6 in half. Okay. So I know what my radius is. I don't know what my slant is. So I need to find my slant. So if I have this triangle here, now where this might throw you off is, oh, well, it's not what we're used to seeing, right? This is just a rotated triangle. All I'm going to do is I'm just going to draw that same triangle like this. All I did was literally, if you rotate your paper, that's what you get. If you turn your paper 90 degrees, you're going to get this. So all I'm doing is I'm just restating this triangle. So I know I have two sides. I'm trying to find the hypotenuse. This is the hypotenuse here, which is also this slant. And you know what? I'm just gonna say it's the S. I'm gonna say it's S, just to keep that consistent. So if I have two sides, I'm trying to find the hypotenuse. What formula do I use for that one?
A squared plus B squared equals C squared.
Yeah. So I need to use, and I'm just writing a note here. This is an example, right? Use Pythagoras to find the length of the slant, which is also the hypotenuse. So this is what I'm doing. I'm writing this note, you're writing this note for future self. So we're using Pythagoras to find the length of the slant. Pythagoras is that A squared. I'm just going to write that a little bit bigger down here. It's A squared plus B squared equals C squared. This is what we learned in Unit 1. So my C is always going to be my hypotenuse. I don't know what that is, so I'm going to leave that alone. But I know what my other two sides are. It's 4.8 and 12.8. So 4.8 plus 12.8. Those are both being squared. And so this is what I saw a lot on those concept checks, is people would literally add these up. They would go, oh, it's 4.8 plus 12.8. I would see this a lot. That's not what we do. Literally, once you've set it up, you can just punch it straight into your calculator as how I see it. It's 4.8 squared plus 12.8 squared. You just punch it in exactly as you see it. Your calculator will do the heavy work for you. So 186.88. 186.88 centimeters squared is equal to C squared. But I don't care what the hypotenuse squared is. I care what the hypotenuse is. So I need to, again, this is what we learned at Unit 1. I need to take the square root of this stuff. Oh, I meant to change that color. So all I'm going to do is take the square root of these. Actually, let's just. And if I do that, well, sorry, what was that number? It's 13.67. Okay. So if I do that, 13.67 centimeters is equal to C. I'm going to underline that. That's important. That is what my slant is. So now I know that my slant, I'm going to color this in blue, is 13.67 centimeters. We did all that work just to figure out that slant. Now I have the two things I need. I have the radius, I have the slant. I can find the surface area of the cone. So all of that work was to find that hypotenuse. In fact, I'm going to draw a little bit of an arrow to right there. Just to kind of show that's what I did. So now I can solve it exactly like how I did up above, where what's my formula? Plug the numbers in, boom, solve it. So now I'm going to find the surface area. I'll go back to red. The surface area of a cone. It's equal to pi r r and s. Again, I'm putting these little times here just to kind of show it. You do not need to do this. Oops. Erase that. But that's technically what's happened. Technically, it's just pi rs. There's little times that are going in there that are happening in the middle of it, though. I'm just doing this just to kind of show you. So then all I have to do now is just plug my numbers in, right? What's my radius?
4.8.
It's 4.8. It's not 9.6. Again, we did this 5 minutes ago. That's why we write those stuff for us. It's 4.8 was my radius. 9.6 is the diameter. So it's equal to pi times 4.8 centimeters times my slant was 13.67 centimeters. So then all I do is I punch that in my calculator and I should get my final answer of,
6.14.
yeah, 206.14 centimeters squared because it's an area. And that's my final answer. Hold on a second, I'm just doing attendance. Okay, so I got two more that we're doing. Oh, you know what? Actually, we only have one more that we're doing. We're gonna skip number 6 for now. We'll come back to this one tomorrow. So we're gonna skip question 6 for now. Actually, don't even exit it out. Don't exit it out. We're skipping question 6. We will come back to that tomorrow. So we're gonna jump straight ahead to question 7 here. So this combines that really annoying problem from from Monday or Tuesday, whichever, or Monday or Wednesday, whichever day it was. It combines the annoying problem from last unit with some new stuff here. What makes this a harder problem?
You got 2 different shapes.
I have 2 different shapes. And so what do I have to account for when I'm finding the surface area of this?
2 different equations.
There's 2 different equations. So let's quickly make my equation for this. Always make an equation at the start. I promise you it's going to come in handy. How do I, in plain English, how do I find the answer, the surface area to this?
Cone plus, or cone plus. Cylinder.
Cylinder. So cone plus cylinder. Now, there's a problem with that though. And the problem is I'm not finding the surface area of the part that they're connected in. So there's this little thing here. This is where those two things connect. I can't find the surface area of it because they're glued together, right? I can't measure that. So I have to take that away. So I'm going to call that circle. I need to take away that circle, not just once. I'm taking it away from the cone part of it because I'm calculating the full part of the cone. I also need to take away the cylinders part of it. So I'm taking away that little red circle twice. Cool. So I have my equation. The tricky part here is you would probably do everything right. The tricky part here is that little circle. Remember, you're not calculating the surface area of that circle. They're covered up. That's where they're glued together. So that's why I'm taking it away, not just once, but twice, because you're taking away that measurement from both shapes. Excuse me. So let's just go through it in order. I'm going to start with my cone. Formula for a cone is pi rs. I'm not going to put those times in there now. I'm just going to do pi rs. There are little invisible time symbols in between there. But mathematicians are lazy. So it's going to be equal to pi. What's my radius of my cone? 3.4 is the diameter of it, right?
So 1.7.
Be 1.7. So my radius is going to be 1.7. Again, that's a really common error to make. It is not 3.4 because the whole thing's 3.4. The radius is half of that. So I just took half of that. So it's pi and then 1.7 centimeters. And then my slant, I have that, it's 8.6 centimeters. You're going to notice I put brackets in there. That's just to kind of like show that they're two different things. You could use time symbols if you want. Don't matter. Either's fine. That's exactly what I did because 3.4 is the diameter of the whole thing, but I only need half of it. So that's why I cut it in half, right? Because this is a radius now. So that's why, there we go. So yeah, that's a good question. So pay particular note to that 1.7. Again, you might solve all of this correct, except that one little thing. It's a common error. Everyone does it. Don't feel bad if you do it. And frankly, if you solve like all of it correct and that was the only mistake you'd make, you'd basically get full marks anyways. So all I now do is I just punch that in my calculator. Should be 45.93 centimeters squared, I think. Oh. Oops. Underline that because that's important. Boom, that's my cone done. So my next thing on the agenda here is a cylinder. My surface area of my cylinder. I'm just gonna put cylinder. How do I find the surface area of a cylinder? Well, that's to find a rectangle. So how do I find the surface area of a cylinder? It should be on the first page of this unit. Surface area of a cylinder. We already did it, right? It's just circle, circle, square, circle, circle, rectangle. Right? Again, you think about the net, it's the circle, and the rectangle. This part right here. So cylinder is just this. Again, this is why it's really important to keep organized, right? Because now you have an equation within an equation. So let's so what do I need to figure out the rectangle? I need the length times the width. I have one of those. But I also need the width of it, which is this little blue line here. You remember what this is called, this blue line? This is the circumference. I need to find the circumference of this. That is what I need to plug in. Again, there's lots of steps involved with this stuff. So I need to find the circumference. So I'm going to do that first. So I'm going to color it blue to show that I'm using it to solve that blue thing there. So I need to find the circumference. What's my formula for circumference?
2 pi r.
C equals 2 times pi times r. You can just do C. Yeah. That's if you know what the C stands for, absolutely. I'm only doing that because it's an example. So C is going to be equal to 2 times pi. Now, what's the radius? Do you think 12.2 is the whole thing, right? Radius is half of that. So it's going to be 5.6. Really important that you understand where this 5.6 came from. I haven't written it down anywhere. I'm taking a shortcut. That 5.6 centimeters is half of this thing. It's half of that diameter. It's usually the circles, it's usually that radius and diameter and circumference thing. That's usually the problem with this unit, is we get confused about, well, which one does, what does that all mean? Your radius is half of your diameter. 11.2 is my diameter, which means 5.6 is my radius. That's where I've gotten that number from. So then all I have to do is just plug that in my calculator. And I should get 35.19 centimeters. Not centimeters squared, just centimeters, because I'm checking the length of a measurement. Okay. So all of this was just to find that circumference. I still need to find the rectangle. I just needed the circumference to do it. So the rectangle, we know that one's just going to be length times width, right? I now have my length, which is 9.3. And I have my width, which is what I found, which is that circumference, which is that 35.19 centimeters. Which if I times together, 9.3 times 35.19 should give me 327.27 centimeters squared. Again, it's usually the circles that are the issue here. We have to understand the difference between a radius, a diameter, and a circumference. They all involve circles, but they all are different things in the circle. So check, I've done that. Now I need to do the cylinder circle. What's my formula to find the area of a circle? Pi r squared. So I'm just going to underline that last one. It's important. Pi r squared. What's my radius? This is 5.6. Yes. 5.6 squared centimeters. Which if I punch into a calculator should give me 98.52 centimeters. Oh. 98.52 centimeters squared. Gonna underline that, that's important. But I am not done. I still need to know what the cylinder is. I have all the keys for it. So the cylinder is one of those rectangles, 327.27 centimeters squared, plus two of those circles, two of those cylinder circles, 98.52 centimeters squared, plus 98.52 centimeters squared. Which if I add all that up is going to be equal to 524.31 centimeters squared. Again, that organization is so important here. If you're just putting random numbers down on here, we've now spent 10 minutes on this question, right? You're not going to remember. Don't trust your memory. It's not as good as you think it is, I promise. I'm going to underline that. That's important. Okay. So I now have another piece of the puzzle. All I need to find now is this little circle here, the area of this little circle, and I have done my job. And then we get a break after this. So I'm going to find the surface area of the circle, that tiny red circle that I have up there at the top. What is the formula to find the area of a circle? Pi r squared. It would be, so this r, this radius, it's not 3.4. It is 1.7. The radius is not 3.4, it's that 1.7. We established that way up above. So 1.7. Oh, God, I'm just gonna write that properly. Oof. I'm gonna type that in. So it's 1.7 centimeters squared. So I punch that in my calculator. Pi times 1.7 squared. And it's going to give me my answer of 9.08. And with that, I got all 4 pieces of my puzzle. I'm just going to zoom out a little bit. I have all 4 pieces of my puzzle. I have those 2 little circles now. So now I can just restate my equation, right? My equation was my cone. So the total surface area, the SA surface area, my surface area of my cone was 45.93 centimeters squared, plus the surface area of the cylinder, 524.31 centimeters squared. Again, we should be seeing now why this organization is huge. And then I'm taking away 2 of those little circles I just calculated, minus 9.08 centimeters squared, minus 9.08 centimeters squared. So all I did was that equation up at the very top that I did, all I did was restate that and I plugged the numbers in. So my total surface area now is just going to be all those numbers combined. So if you punch that in your calculator, you should get 552.08 centimeters squared. And that's my final answer. I'm going to circle it. Again, there are ways to shorten this. It doesn't always need to be this long. You could just say, hey, the surface area of the circle, you could do all of this stuff here, these 2 steps on your calculator. I don't need you to restate the blank formula. I don't need you to show like that middle step. Well, it's helpful on a concept check, but if you want, you could just say the surface area of the circle is 9.08, and that is better than nothing. So I'll give you a second here to write this down. There's going to be a couple things you're going to have to change in the questions below. So we'll do that and then we'll go for our break. So I'll just give you guys another minute to write everything down. Yeah, everyone has that. So there's a couple things you're just going to have to add. So if you go on down to page 32. So in this pyramid here, you see how there's this little like true height there? The true height here. The height is the square root of 245. Centimeters, I guess. So question 7 on page 32, the height, this red line here. Make that a little bit thicker. This red line here, that is 200, the square root of 245. So I'll just give that to you. We will eventually learn how to do that later. Pyramids, you need the true height. The only thing you don't need the true height for is a cone. Sorry? It might be in this course or it might be in next one. Well, okay. Maybe tomorrow. I'm kind of thinking I might try it tomorrow and we'll see how it goes. Question 8. Just skip it. Same thing with question 9. We don't need to know about more than square pyramids. And then I think the rest of it, we were good on, if I recall. Yeah, the rest of it we're good with, I'm pretty sure. So skip question 8, skip question 9, put that information in for question 7, and we should be good to go. I know it's a lot of information. Do your best. Please ask for help if you're not sure. It's really important we do get this down. Keep yourself organized. Don't just write numbers all over the place randomly. I promise you it's going to end in disaster.